so that you can mark yourself and give us the feedback after marking yourself at the end of the day. So inbox me, you forward it to my email so that I can see how you performed. Last week we looked at the solar system. We looked at the solar system. Then from the solar system, we went ahead to look at the Earth, where we live. And we look at the fact that why is it unique? Why is it different from all other planets? And I hope you generate your own notes about that. Then look at the facts about the Earth, which I have just told you, informed you that I have posted the answers to those questions. Please do mark yourself. Today, we are going to look at the shape of the Earth. And the guys are supposed to be noting as you'll be watching, doing this, remember to make your own notes. My work is not to give you notes, that's my work. So today we are looking at the shape of the Earth. So we can listen to this video, then after that, you give me a summary of what, okay? So that's what I'm going to do. I'm going to play this video. I'm looking for sound, share. Then you give me the answers.
Charlie, not hearing.
Yes. Just a minute if you're not hearing, but you have shared with us sound. Okay.
On Earth. Earth has a diameter of roughly circumference. They use positions of stars and constellations to estimate distances on Earth. Earth has a diameter of roughly 8,000 miles and is round because gravity pulls matter into a ball. Yes, people often think of Earth as a gigantic sphere, but its shape is not quite like that. It's not a perfect sphere. Appearances can be deceiving. Due to the force caused when Earth rotates, both the North and the South Pole are slightly flattened. Earth is really an oblate spheroid because its spin causes it to be squashed at its poles and swollen at the equator. But don't we all know that the Earth is not really a sphere because of the oceans, the mountains, the valleys, and these features are not part of a sphere or an ellipsoid? Well, this irregular shaped ball is called geoid. And a geoid is used by scientists to more accurately calculate depths of earthquakes, for example. Geoid means model of the figure of Earth, that is, of the planet's size and shape, that coincides with mean sea level over the oceans and continues in continental areas as an imaginary sea level surface defined by spirit level. It serves as a reference surface that can be used to measure precise elevations of Earth's.
Hope girls, you have followed and you heard something about this video, about the shape of the Earth. Hope you have been listening and you have been writing something. So from there, I move to another slide. So turn to your, I hope you have your books. Turn to page 49, and there's that activity, which is 5.1. Once you say identify the position of the poles and the equator, describe what the Earth looks like at the poles and at the equator, then describe the shape of the Earth. That's what we're going to do now, after listening to that video. So on page 49, that is the activity. So can you identify the position of the poles and the equator? Describe what the Earth looks like at the poles and at the equator. Describe the shape of the Earth. You have 5 minutes, 3 minutes. 3 minutes. 3 minutes. So as you are looking at the activity, I hope you can see me. They are saying the earth is not like this. It is not as face, not round. They are saying the earth is in this position. You see, if you look at the first one here, this one here, it is round. When you look at this one here, it is not, this orange here, it is not round. So the earth is like this orange. So you see on top here, we have the northern pole, then here we have the southern pole. Then here, this is where we have the equator. So that's why I say identify the position of the pole, this position of this one, then the equator, then describe how. So if you look at here, no. You first give me the answer, then I'll tell you that. Then they said that from this, then we get this, a geode. You see this. Okay, it is a geode. It is not this. This one. So it is from here. From here, then we go into this. As you can see, I'm holding two things representing the shape of the earth. So there we go. I'm waiting. Okay, who is my timekeeper? Timekeeper, Mr. Nasumol, is it time?
It is time.
So can you have now contribution from the girls? This is senior one. I love senior one.
Our default.
For number one. Okay, teacher, I wanted to answer number 3.
I start with the first one before you go to number 3. Why are you skipping number 1? What before? Why are you skipping number 1? Because number 1 lead to number 2, then give us number 3.
Let her make her submission.
Okay.
She will realize where the challenge is later on, I think.
It has an irregular ellipsoid shape.
Have an irregular geoid shape. Okay. Have an irregular orange shape. Okay.
I have a Tukunda, Vanessa.
Teacher, for
Yes.
number 1, the poles are found at the top and at the bottom of the earth, and then the equator is found in the middle or around the earth.
Okay, can you repeat, please? Can you repeat?
The poles are found at the top and at the bottom of the earth, and then the equator is found in the middle around the earth.
So, which is found at the pole, which is found at the top? What's the name? This one here, the name, what's the name?
The North Pole.
This pole, how do you call it? The North Pole, then this here? Here?
The South Pole.
You said this is the North Pole, then the South Pole. Thank you. Please, girls, I hope you are writing down. At least there we are now. So identified, the North Pole is found at the top. The southern pole is found in the at the bottom.
North
Mhm.
Pole, the North Pole, the South Pole, and the
The North Pole.
Those of you whose microphones are on, please. Giweji,
Yes.
You die when you go to that.
Yeah, for number
Giweji?
two, the Earth is flat at the poles and swollen at the equator.
So flat at, it is flattened at the
Poles.
flattened at the poles, the north and the south, and then it is what? It is,
Swollen at the equator.
then flat, it is what?
Swollen at the equator.
Swollen at the equator. Thank you. So that
Sasa
is,
Mogere,
yes,
a minute.
yes.
A minute.
Yes, sir.
Musubika and the rest who are putting on their microphones, please let us control ourselves. Don't talk unless you have been asked to. The next action will be moving out to the waiting room.
Okay. So it is flattened at the poles. This is the northern pole, and then flattened at the southern pole. Then it is swollen at the equator. So, but if you look at this one, this is not flattened at the northern pole. It is smooth and then it is round, but it is swollen at the equator. Guys, I hope you're writing down now. You have answered all these kind of activities. Can you write down? You have 2 minutes. Turn down your points.
Excuse me, teacher.
So flattened at that. Yes. Yes, go ahead.
May you
Yes.
please repeat? May you please repeat the answer for number 2?
Number 2, who gave us the answer, Banagi? Who gave us the answer?
Lina.
Please.
The answer for number 2 is the Earth is flat at the poles and swollen the equator.
So flattened at the poles and then swollen at the equator. Thank you.
Excuse me, teacher.
There is a hand
Yes.
from Namoviru.
I want you for
Num-
please repeat her answer for number 3.
Number 3, our default, please.
You put up the hand and then we'll choose you. There is a hand from Namoviru.
Charles asking, instead of
Asking our
saying,
default. Our default, please, can you answer Nambiru's question?
no, Charles, not a question. Asking
Nambiru asked.
instead of like saying swollen, can you say it's bulged at the equator?
Thank you. You are the best. Wow. Bulged at the equator. Instead of using the word, you can say swollen, it is bulged at the equator. You're wonderful, Nambiru. Thank you.
Nanyanzi
I
Hosana.
can say another hand. Nanyanzi.
Nanyanzi.
Yes, teacher. Teacher, I was off and I didn't get the answer for number 2.
For number 2. Number 2. Okay. Yes, I can see Namagembe. Namagembe. Namagembe.
Teacher, I also have a question that number 1, the answer, okay, I've joined late due to any problems. I think when I wrote it, but I didn't get that. I've joined, okay, I've just joined actually, so I don't know what we are on.
They said that. Wow.
Sasa Mogere.
Yes, sir.
Maybe to guide the session, if for example, you join late and you find us in the middle of the session, I would advise that you wait, allow us to proceed. Then we are going to have time to open so we can be able to get the ideas, because we cannot keep moving forward and going back again. At the end of the day, we're not going to be able to meet our objective.
Maybe they can put them in the chat and open.
Yeah, in the chat. And then 2, this whole session is recorded and someone can be able to access the whole session at the end.
Okay. Yes, I can see Chirabo.
Okay. Teacher, may Adifo please repeat her answer for number 3? You didn't say it clearly.
Okay,
Yes,
okay,
teacher.
okay. Okay, our default.
Okay. The answer for number 3, I say you can say an oblate spheroid shape, or you can say irregular ellipsoid.
Okay, thank you. So they have given all the answers. It means the Earth is not truly in a spherical shape. And we are saying for number 2, it is slightly flattened or squashed at the north and then the south pole. And then it is swollen or bulged at the equator. So you see this, if you look at here, it is flattened at the top, then down. The northern point is flattened or squashed at the southern pole. Then it is bulged, or it is swollen at the equator. So is it clear now? If you can pick, because I picked what you have been saying, that's why I put that notes there, so that you can write and you see what you're talking about. So you may say that the shape, in basic knowledge or basic education, the shape of the Earth is described as being an orange. Because if you look at this orange I'm using, it is flattened at the top, and then it is flattened at the bottom. So this is the northern pole, this is the southern pole. Then it is bulged at the equator. But if you check the cricket ball, it's not in that like that. It has a curve, a northern pole, and it has a curve, but it's also swollen at the pole. So it's not like this. If you want to be this on this cricket ball to be like that, it means it must be in this form where I'm using now, I'm adding pressure on it so that it is flattened at the north pole, bulged at the equator, then flattened at the southern pole. You see this now. But if it is in this form, no. So it is less. That's what it is. At the end of it, it is a geode. From here, then we get less. Because as we heard from the video, because of the mountains, the valleys, the oceans, making it to be in this, that's what they call the geode at the end of the day, in this form. There's a question somewhere. Chirabo?
Teacher,
I can see your hand. Yes.
Point number 4, the facts of the shape of the Earth said the bulging of the Earth at the equator is caused by the constant spinning of the axis.
The constant,
Since
yes.
other planets also rotate, does it mean that all planets are in the shape of the Earth? Like none of them is round?
Yes, at the end of the day.
Thank you.
You're welcome. So we are saying that if you look at the diameter, okay, we're talking about why it's not spherical, why it's not round. Because if you look at the diameter, the equatorial diameter and the diameter of the pole equator, they're not the same. As we can see here, you see that. So the equatorial diameter from here to here, you can see this is the figure. Then for the north and the southern pole, the pole diameter is here. So that's why it is obsolete spherical in nature or in shape, because we don't have equal diameter. So the diameter, the equatorial diameter is non-equivalent. It is not the same as that of the polar diameter. They are slightly different, making to be in this form, not less. Because if you can list to me, they have the same diameter. So from here, just a minute. So from this point to this point, and then from this point will be equal to make it to be in this form. So the polar diameter is not equivalent. They are not the same. diameter to that of the equatorial diameter. You copy? Can we continue?
Yes. From the chart, please may you post. Okay, this will be handled later on.
Okay, that will be handled later. Okay. So we'll go to activity 2.5.2. Using your atlas, draw using your atlas. Please draw the shape of the earth. I need to mark and name the main lines. If you check with in your book, you have that question there. That is activity 5.2. Please, you have 2 minutes to draw. So use your atlas and please draw. You have 2 minutes. So this is what I'm expecting to be having at the end of that day as you sit here. So I've given the activity and I've given even the answer. Even that. Teacher Semogel, not serious.
Teacher Semogel.
Yes, ma'am.
Teacher Semogel, you
Yes,
said
ma'am.
the main lines of latitudes and longitudes.
Yeah, this
and
one.
the diagram I'm seeing on the screen, they seem to be many. Are all those main?
They are all main now. I need all of them.
You need all of them. So you need to be specific to the girls, otherwise they might just pick the 3 main latitudes.
Please, can I have all the lines? Those lines as you see them there. Not the main ones, all of them in general.
A question from Nakalema, should we draw with the compass?
Nakalema, we said, remember,
What
if you're
does
going to
she
use,
think?
what do you think? Nakalema.
Yes.
Please, you're supposed to use those. If you're going to use the compass, please use the compass so that you draw. If that's what you're going to use, we have no problem with that.
But
Use
you
whatever.
said
the shape. You remember the shape. You're not supposed now. Now you have answered yourself.
that shape.
Yes, that shape. You have answered yourself. Luckily, you're a good student. So you ask a question and then you answer yourself. So if you go to use the compass, what is it? You're going to get some which is, you're going to get this. Not so? You will not get this, which is the same as you said here. The top. Our class monitor, Mr. Nasumo, are we done?
Just seconds, then I'm going to call out. But as we prepare,
as we prepare,
from Lena, when we are continent bodies, that's the question.
What?
Do we also, when we are drawing the earth, are we to also draw the continents and the water bodies?
It is the thing is clear. Have they seen the continents here? Or have they seen the water bodies here?
No,
Our time is
like
up.
on other drawings.
Other what? Which other drawings? This
Like
one?
the one where we were supposed to draw the solar system, or this one of the diameters.
No, this one you can just show when you minus these ones, okay? Just also how which is blank, right? Just to give you the idea. Just to give you the idea, minus the continents and the water bodies, if you talk about this one. Just forget about that. Just draw and indicate the equatorial diameter and then the polar diameter. As simple as that. Don't make your life to be complicated. Okay?
So our time is up. We can proceed with the discussion.
You can proceed with the discussion as guys were doing. Now, if you look at your textbook, it says that the Earth makes two types of movements. And this includes the Earth's rotation and the Earth's revolution. Please, can you have that in your books? The Earth makes two types of movement. The Earth's rotation, that is one movement. The second movement, that is the Earth's revolution. Remember, as we are moving, we are making notes, we are making our own notes. People are saying that we must post the notes. Hey. So are we there? Can we now listen to this one here? It is another interesting point.
The Earth and its movements. The Earth is the third planet from the Sun. And it has a unique characteristic that no other planet we know has. It's the only one that has life on it. Life of all types, plants, animals. Its average temperature is 15 degrees Celsius, and because our planet also has water and an atmosphere, it is the perfect place for life. Like other planets of the solar system, the Earth moves in two different ways. One is called rotation, and the other is called revolution. Rotation is the movement of the Earth on its own axis. Rotate means to turn, so the Earth turns around a slightly inclined imaginary line that joins the two poles called the axis. Do you know how long it takes to make a complete turn? It takes 24 hours to make one rotation. Think about it for a second. One day and night together, lasts 24 hours too.
Yes, sir.
So the movement of rotation causes day and night. Interesting, right?
Mine it is okay.
Now let's see the movement of revolution. As you can see in the pictures, the Earth goes around the Sun in an elliptical orbit.
Mr. Nashmul, it might be
That
your
might
side.
sound a little strange, but if you look, you'll see it's simply the journey that the Earth makes around the Sun. Do you know how long it takes the Earth to make a complete revolution around the Sun? Well, it takes 365 days. Exactly 1 year. This revolution movement is what makes the spring with its colourful flowers. The hot summer full of fun. The autumn when leaves fall from the trees to the ground. And the cold and frosty winter. So let's remember the two kinds of movement that the Earth makes. There is rotation, which is the Earth turning around itself, causing day and night, which lasts exactly 24 hours, the same as a whole day. And there is revolution, which is the Earth traveling around the Sun, which takes 365 days and causes the seasons. So now you know the movements of the Earth. Goodbye everyone, and don't forget to subscribe to Happy
Good
Learning.
morning to everyone. So I think you have listened. So we can talk about revolution. So rotation first, and then revolution.
Excuse me, teacher.
Chirabo?
Yes,
Yes.
excuse me, teacher. I had a question.
Yes.
They say that the Earth revolves around the sun in 365 days. Now, what causes a leap year? Because we know that when a leap year happens, there are 366 days.
Okay. Okay, that's what is going to be answered. Thank you. Thank you. It's going to be answered. Our default.
Yes, teacher.
Mm.
We're going to talk about rotation.
Mm.
So according to the video, rotation is the movement of the Earth on its own axis, and it causes day and night. The video says 24 hours, but the other time I was searching, say that it takes 23 hours or 56 minutes. Yeah.
Okay, thank you. Charity?
So I want to add something to rotation. It also says that the rotation of the Earth. So can you hear me? So I'm saying that I want to add something about rotation of the Earth. The rotation of the Earth also causes day and night. Yeah.
Okay, thank you. Thank you. Any other? Atuhairwe.
Yes, teacher. Yeah.
Your hand is up.
Yes. I want to talk about revolution. So the revolution refers to how the Earth moves around the sun, and it takes approximately 365 days, which is a year, and also causes the changes in seasons. Summer, spring, autumn, and winter in different parts of the world.
Thank you, Athaire. I hope girls, you are not taking note of that. I have, yes, has disappeared now. Adeke.
I wanted to give the same answer.
Same answer,
Yes.
okay. Okay.
I give it.
Yes, go ahead.
I wanted to say that revolution involves the movement of the Earth around the sun, and it takes about 365 days, which is a year. It causes a change in the different seasons.
Okay, thank you, Adeke. Vivian, do you have something to say, Vivian? Vivian have disappeared now.
I also wanted to say the same. Sorry.
The same thing, thank you. Namagembe, do you have something? Namagembe?
Teacher, I wanted
Yes.
to say that yeah, just adding up something about revolution. That revolution causes different changes in seasons, such as spring, winter, summer. It also causes coldness or hotness.
Okay.
And it also refers to how the Earth moves around the sun. Yeah.
Okay. Thank you so much. Nanyanzi, do you have something to say, Nanyanzi?
Yes,
Nanyanzi?
about rotation.
Yes.
I have both an explanation, also a question. First, my explanation. Yes, rotation it takes like 24 hours a day to move for it to turn, to make a complete turn. Then it causes day and night. Then it also causes difference in time, and it also affects ocean currents and tides, and also influences the direction of the prevailing winds.
Okay, thank you.
Then my question, I wanted to ask. Yes, I wanted to ask, where does like climate change come there in what? In rotation of the earth. Is it there, climate change?
No, we don't have climate change under here when we talk about rotation. It is who responsible for the climate change. You and me. We're the only responsible for that change. Okay? It's not about the rotation. That change you're talking about, maybe talk about change in the length and then temperature. Yes, Chirabo, we want to move on to something different. Okay, Tendo, sorry, Tendo. Tendo. Tendo, your hand is up.
Excuse me, teacher.
Yes.
I wanted to ask that Hosanna said that what causes climate. So for me, I'm just guessing, trying to say something, what I think. Just here, they say that revolution makes difference in seasons such as spring, coldness, winter. So I think also it makes it in changes of climate, because in spring there are in winter there is what cold weather, which is the different climate. Or in spring and summer there's also a different one. So I think that's how it changes the climate. Because it's more of a change in seasons, and in the seasons there are different climates, equatorial, tropical. So I think that's how.
Thank you, Tendo. Thank you, Tendo.
Mr. Semogerere?
Yes.
Maybe the girls can demonstrate this at home. For example, if they placed light on one side, and
Mr. Nasumo, just a bit. Let us continue. Don't worry. It is coming.
Okay.
Okay, guys, can we introduce one now? And then we conclude and give me the final point. Can we introduce one?
Let us learn rotation and revolution of the earth and its effects. The spinning of the earth around its own axis, which is an imaginary axis, is known as rotation of the earth. Now this axis is tilted at an angle of 23.5 from the vertical. And with this tilted axis, the earth revolves around the sun, and that is known as revolution. So these are the two important motions of the earth, that is rotation and revolution. The axis of the earth is an imaginary line passing through the center of the earth as it does on the globe. The two endpoints through which the axis passes is known as North Pole and South Pole. The axis is tilted at an angle of 23.5 from the vertical. This means that if a line were drawn parallel to the plane of the Earth's orbit, the Earth would make an angle of 66.5 degrees to this line. Now let us understand the characteristics of rotation. The first one is direction. The Earth completes one rotation from west to east on its axis in 23 hours, 56 minutes and 4.09 seconds, which roughly comes to 24 hours. Then it is inclination of the axis of the Earth. The Earth is always tilted in the same direction. That is, it is pointing towards pole star. That is, its north pole is pointing towards pole star as it is moving around the sun. Third is the speed of the Earth's rotation. The speed of the Earth's rotation at the equator is 1,670 kilometers per hour, because the circumference of the Earth is 40,070 kilometers. So at the equator, the Earth would be traveling 40,070 kilometers and it is covered in 24 hours. So in 1 hour, the Earth rotates 1,670 kilometers per hour. So if we sum up the characteristics of rotation of the Earth, it is the Earth completes one rotation from west to east on its axis in 23 hours, 56 minutes, 4.09 seconds. That is roughly 24 hours. The earth is always tilted in the same direction as it is moving around the sun. And the speed of the earth's rotation at the equator is 1670 kilometers per hour. Now let us learn the effects of rotation. The first and the important effect is the day and night are caused by the rotation of the earth on its axis. This is because a part of the earth faces the sun and it has day, and the other part which does not face the sun has night. And this happens with precision and progression and not suddenly. So I will say this happens accurately and gradually. It does not happen suddenly. The time when the sun begins to cast its light in the morning is known as dawn. At noon, the sun is overhead. At dusk, that is in the evening, we see the twilight. Twilight is the light that we see after the sun sets. So here, the sun is disappearing in the sky. At night, we all know it is so beautiful and completely dark. The duration of the day and night is not equal at all the places on the earth. This is because of the inclined axis of the earth. If we look at the important latitudes on the earth, it is equator, Tropic of Cancer, Tropic of Capricorn, Arctic Circle, and the Antarctic Circle. Now, if you see the lines carefully in the southern hemisphere, you will understand that the duration of night is longer, and in the northern hemisphere, the duration of day is longer than the night. The reason is the northern hemisphere is facing the sun and the southern hemisphere is facing away from the sun. But if you look at the Arctic Circle and Antarctic Circle, the Arctic Circle is completely in day. So when the earth is rotating, the entire region beyond the Arctic Circle will have day. There the sun will not set. Whereas in the southern hemisphere, beyond the Antarctic Circle, you will see it is completely dark. And here the sun will not rise. The length of the day varies with respect to even seasons as well as latitudes. So the length of the day varies with respect to latitude but also seasons, and we shall be learning about them gradually. Then it is the sunrise and the sunset. This happens because of rotation of the earth. Then it is the Coriolis effect. Now we all know that the earth is spinning at a great speed. At the equator, it is 1670 kilometers per hour. Second, we have learned that because of the spherical nature of the earth, different part of the earth receives different amount of sunlight. So there is difference in temperature at different places. Because there is difference in temperature, there will be difference in pressure. Some places will have a high pressure and some other place will have a low pressure. And because of that, the wind moves. The wind always moves from a high pressure area towards low pressure area. Now, when the wind is moving on the surface of the earth, the wind bends. The wind bends because the earth is rotating at a great speed. In the southern hemisphere, the wind will bend towards left, and in the northern hemisphere, the wind bends towards right. Now, when you look at these arrows, it is very clear that they are bending towards left. But when you're looking at these arrows, it will appear as if they are also bending towards left. But for the arrows in the south, you will be looking from the southern end. Similarly, for the arrows in the northern hemisphere, you have to look at it from the northern end. Then you will see that they are actually bending towards right. So the wind in the northern hemisphere always bends towards right, and in the southern hemisphere, they bend towards left. But in the equatorial region, that is region between 5 degrees north and 5 degrees south, the wind does not bend. These are the regions of doldrum, or we say these are the regions of calm, and these are the regions of low pressure. The next important phenomena that we see is the sun, the moon, and the stars seems to move from east to west. Now you may say that you have seen sun moving from east to west. What about the moon and the stars? But actually, if you see in time lapse, you will understand that they all are moving from east to west. This is because the earth is spinning from west to east. Now, this effect is similar to what one experiences while sitting in a train and looking out of the window. What do we see? We see the trees and buildings and everything moving in the opposite direction to that of the train. The reason is the train is moving at a very great speed. The same happens with the earth. When you look at the sky, it appears as if the sun, moon, and the stars are moving, but actually the earth is spinning on its imaginary axis. Then the earth also generates centrifugal force. Centrifugal force is the force that is generated from the center towards the periphery, that is towards the edges. This is because the earth is spinning at a very great speed. It is the same effect that we see every day in our kitchen when we are operating a mixer. All the chutney will come and stick on the edges of the glass. And this is the reason that along the equator there is a bulge in the earth, and the earth is said to be geode shaped. Then rotation also causes difference in time, because when the earth is spinning, some part of the earth has day and some other part has night. Some part of the earth there is sunrise happening, and somewhere else the sun is setting. So different part of the earth will have different time. Then the short rotational period makes the variation of temperature between day as well as night moderate. So neither day nor night is extreme, it is moderate. The rotation and revolution also causes seasons and variation in the length of day and night, and we are soon going to learn that. So let us summarize the effects of rotation. The effects of rotation are occurrence of day and night, sunrise and sunset, Coriolis effect. The sun, moon, and the stars seem to move from east to west. Centrifugal force, rotation, and we have seen rotation causes difference in time. And the last one is the side of the earth. Now we have seen that the earth is spinning around its own axis, and this axis is tilted. With this tilted axis, when the earth revolves around the sun in an elliptical orbit, that is the orbit that appears like an ellipse. Ellipse means an elongated circle. So when the earth is revolving around the sun in an elliptical orbit, we call it as revolution of the earth. And this leads to various phenomena. The earth moves at an average speed of 29.8 kilometers per second, or it is easy to remember 1 lakh kilometers per hour. So earth is spinning at a speed of 1670 kilometers per hour, and the earth is revolving around the sun in an elliptical orbit at a speed of 1 lakh kilometers per hour. Now if we see the revolution, the sun is not exactly in the center of the ellipse. Because it is not at the center of the ellipse, the earth, when it is revolving around the sun, there are times when it is closer to the sun, and there are times when it is far away from the sun. When the earth comes closer to the sun, that time the speed of revolution around the sun increases. And when the earth is away from the sun, the speed of revolution reduces. This is mainly because of the gravitational force of the sun. Now, the earth completes one revolution around the sun in 365 days, 5 hours, 48 minutes, and 45.51 seconds. But we roughly take it as 365 days, and 6 hours. Now to adjust this 6 hours, we have the concept of leap year, and leap year comes once in 4 years. So on the 4th year, February, instead of 28 days, we have 29 days, and in this way we adjust this 6 hour. Let us learn the effects of revolution of the earth. The first effect is the seasonal changes. Because of the revolution of the earth, we have in the first phase summer, in the second phase rains, in the third phase it is retreating monsoon, and in the fourth phase it is winter. Now how does this happen? Suppose we take these 4 positions of the earth. In the first position the date is 21st of March. In the second position it is 21st of June. In the third position it is 23rd September, and the fourth position it is 22nd December. When the earth is in the second position, if you look carefully, the northern hemisphere is facing the sun, and when the earth is in the fourth position, the southern hemisphere is facing the sun. But when the earth is in the first position or in the third position, none of the poles are facing the sun. So the inclination of the earth's axis does not have any impact on the sun rays that it receives. So on 21st of March, vertical rays of the sun falls on the equator, and the entire earth has equal day and equal night. But as it is moving from the first position to the second position, slowly the northern hemisphere tilts towards the sun. So in the northern hemisphere, the days become longer and the nights become shorter. And this gives rise to summer conditions, and we say in this phase it is summer in India. On 21st of June, the vertical rays of the sun falls on the Tropic of Cancer. This is the maximum inclination of the Earth's axis of the northern hemisphere towards the sun, and this is referred to as summer solstice. As we come to the third position, once again the day and night are equal, and in this phase India experiences rain. When the earth comes to the third position, entire earth has equal day and equal night. And as we come to the fourth position, the date is 22nd December. The southern hemisphere is facing the sun, and the vertical rays of the sun falls on the Tropic of Capricorn. And this is the time the northern hemisphere experiences winter solstice. So the first and the third positions are referred to as equinox because it is equal day and equal night. The first position is referred to as spring equinox, and the third position is referred to as autumn equinox. Then, as the earth is revolving around the sun, there are times when the earth is closest to the sun, and this position is called perihelion. And when it is furthest from the sun, it is called as aphelion. When it is closest, that time the distance is 147.3 million kilometers. And when it is furthest, that time the distance is 152 million kilometers. The minimum distance of the earth from the sun is reached on January 3rd, and the maximum distance that is furthest from the sun, the date is 4th July. So aphelion happens on 4th July and perihelion on 3rd January. Next effect of the revolution is the creation of heat zones. The entire earth can be divided into heat zones like the torrid zone, which lies between 23.5 degrees north and 23.5 degrees south. This region is referred to as torrid zone or the tropical zone. Beyond 23.5 degrees north as well as south up to 66.5 degrees, the region is temperate zone. Beyond 66.5 degrees in north and south, it is the frigid zone. So there are creation of heat zones. This again is because of revolution of the earth. So if we sum up the effects of revolution, it is first one, the seasonal changes, inclination of axis and the seasonal changes, perihelion and epihelion positions, and creation of heat zones.
Thank you.
Thank you.
Yeah, this is interesting. Girls, if you look at your learner's book, we have covered all the work which you have. After watching this video, we have covered all the work on page 50, page 51, page 52, page 53, page 54, and page 55. So if you've been following and listening attentive and writing down, we have covered all this chapter, if I'm not mistaken. So any question before we continue? Because we have 5 minutes? 2 minutes. 2 minutes. Yes, girls.
There's someone called Seryoung a vagina.
Vagina. There's someone who has a very inappropriate name.
They try to deal with that person. Sorry for that. Somebody is working on that. Yes, girls, do you have questions, contributions? Yes.
Could you explain more about inclination of axis and seasonal changes?
Okay, I'll do that. Any other? Any other?
Excuse me, teacher. May I explain about the perihelion and aphelion positions?
Teacher, please explain the centrifugal force, something like that.
Okay.
Yeah. Another thing, maybe please also explain that this speed at which the Earth revolves around the Sun, the one LAKH kilometer
per hour, okay.
So then the one for rotation of the Earth, the effects, he said something about the side of the Earth. I didn't understand it.
Which side is facing the sun?
Yes.
That's what we're talking about. The side which is facing the sun and which is not facing the sun.
Teacher, also the centrifugal forces.
Teacher, in the video he talked about the revolution of the Earth when it is moving around the orbit. So can I say my definition as the revolution of the Earth is the movement of the Earth orbiting around the sun?
Okay, that is okay.
Teacher.
Yes.
They talked about the rays over the northern hemisphere has rays bending. Like I didn't really understand that part. Do they bend? Yeah.
No, because of the inclination, they don't bend. Because remember, it's not straight; it is inclined at 23.5 degrees. That's what we have. That's why you have that kind of change because of the inclination of the Earth.
Teacher, then the ones of the northern hemisphere, they inclinate like towards the right or the left.
Okay. The Mary said it is to move in the same position, does not change its position.
Excuse me, teacher.
Yes.
Teacher, he was okay. In the video they mentioned something about like at the equator there is like lower pressure, and then at the
high
north,
pressure.
Yes, I didn't understand that.
High pressure, low pressure. Okay. Now, can I request? Yes, because we have run out of time.
Teacher,
can I request? Yes.
Can you say that the Earth rotates on its axis and revolves on its orbit? Or there is another name for the orbit?
No. There's not any other name. So can I request, girls, can you forward those ones on my email so that I can look at them and answer them? Can you forward them to my
email?
Which you are using, which I'm using when I'm posting your work.
Right?
When I'm posting your work.
Okay,
what you do, go to the Google class, okay? Go to the Google class, you're able to see that. Then I'll get the questions, okay? Go to the Google class. Some people have been using the Google class too, by the way.
And tap reply, and then you put your question.